Hi classmates, I hope you all are doing well. So for this problem, it's already in factored form. So in order to find the zeros of this polynomial, it'll be pretty simple. But trying to figure out the leading term of this problem is pretty difficult. So since there is quite a bit to this problem, you gotta get good at mentally knowing what the leading term will end up being instead of just multiplying everything out, because that'll take a while and you'll have a ton of terms. So for this problem, we can see that the 1/10 right here is positive. So that's going to be distributed to the rest of the problem. So we know that it's going to be positive, so it's going to be 1/10 x, and then you just FOIL everything out and continue. But there's this squared right here that applies to everything in the parentheses. So you know there's going to be x squared. That's going to be one of the terms, and then you keep on FOILing. And then over here, we see that everything in the parentheses is cubed. So if we take a mental note, we'll know that we'll have x squared, and then that would be multiplied by x cubed. And then when you multiply exponents, you're really just adding them. So you'll be left with x to the 5th. So the leading term would be x to the 5th. And since we know that the 1/10 is positive, okay, so since we know that the leading term is 1/10 x to the 5th, we know that the graph is going to be trending upwards. It's going to have a positive slope. And since it has an exponent of 5, and 5 is an odd number, the ends of the slope are gonna be opposite of each other, because positive exponents will have end behavior that goes in the same direction, but since it's odd, they're gonna have end behavior that goes in opposite directions. So it's gonna look something like this. That's going to be what kind of line we're going to be seeing. But then we got to figure out what's going to be the stuff in between. What's going to happen in between with the x-intercepts and everything else. So to find the zeros for this problem, it is super easy since the whole problem is factored already. So we just want to focus on these parts right here that we could set equal to 0. So we have x plus 1. You set that equal to 0. We have x minus 3. You set that equal to 0. X plus 1 equal to 0. You subtract 1. Subtract 1 on both sides. You have x equals -1. And then same thing with x minus 3. To get rid of the minus 3 next to the x, you add 3 on both sides. And then you get x is equal to positive 3. So right here we have our x-intercepts now. X equals to -1 and x is equal to 3. So that's going to help us start our graph. And the domain for this problem is all real numbers, since it is a polynomial, and the domain for all polynomials are -infinity to +infinity. So all real numbers. Okay, and one of our last steps is to find the y-intercept. So to find the y-intercept, you always got to remember, to find the y-intercept, you set x equal to 0, and to find the x-intercept, you set y equal to 0. So since we're looking for y in this situation, we're going to set x equal to 0. So you have f of 0 is equal to 1/10 times 0 plus 1 in parentheses, and that's going to be squared, times 0 minus 3 in parentheses, and that's going to be cubed. So this is what we have right here to set x equal to 0. That is what we're going to be looking at. So let's just simplify this. 0 plus 1, that's just 1, and you keep the exponent of 2. And then you have 0 minus 3 just stays as -3, and then you keep the exponent of 3. So this is what we have after we simplify. And then we are going to execute the exponent. So you also have the 1/10. So 1 squared is just 1, so you could just leave the 1/10 right there. But then we have -3 cubed. -3 times -3 is 9, but then you have to multiply by another -3, so that becomes -27. So then this is what we have. And then we just multiply straight across, since it's multiplying fraction. So then you get -27 over 10 is your y-intercept. And that comes out to about 2.7. So our final step before we are able to graph this polynomial is to create an x-y table to get a better understanding of what's going to be in between the different end behaviors that's going to be in between the graph. So for our xy table, what I want to do is -2 and +2. So you see that here, my xy table. So what I want to plug in -2 into the function first. So it's going to be f of -2 is equal to 1/10 times -2 plus 1 in parentheses, and that's going to be squared, times -2 minus 3 in parentheses, and that's going to be cubed. So this is what it's going to look like once you plug that in. And then you just simplify what's in the parentheses. So you have -1 squared, and then -2 minus 3, that becomes -5 cubed. You bring down the 1/10. -1 squared is just 1. And then times 1/10, that becomes just 1/10. But then you still have the -5 cubed. So -5 times -5, 25, times -5 again, -125. And then, so you're left with this 1/10 times -125, which just becomes -125 over 10. So your x value right here is -2, but your y value is -125 over 10. And now what we're going to do for the other problem, for the other x value, we're going to plug it in. So it's going to be f of 2 is equal to 1/10 times 2 plus 1 in parentheses, that's going to be squared, and then times 2 minus 3 in parentheses cubed. So this is what's going to look like. And then we just simplify again. 2 plus 1 is 3. That's going to be squared. And then times 2 minus 3. That simplifies to -1. And that's going to be cubed. Bring down the 1/10. 3 squared is just 9. So that's going to be multiplied by 1/10. And then also -1 cubed is just -1. So you have 1/10 times 9 times -1. So we simplify that to 9 over 10, and then you multiply by -1, so -9 over 10. So that's your y value when x is equal to 2. Okay, so now that we have all our information that we need to graph, we are ready. So I have my graph right here. It goes up to 10. So what we want to do first is plot our x and y intercepts. So we have x is equal to -1. So let's plot that, -1, put a point there. Have my first point at the x-intercept. Now we have another x-intercept at +3. So let me plot that one too. We have our other x-intercept right there at x equals +3. And then we have our y-intercept which is negative 27 over 10. So that's 2.7, negative 2.7. So we got 1, 2, and then almost to 3, but not quite. There's our y-intercept. So we have our two x-intercepts and our y-intercept. So now that's not enough information to accurately graph it. So we have our other two values. We have our values from the xy table, which is negative 2, and then y is equal to 125 over 10. And then we have our other x value, which is 2, and then y is equal to negative 10 when x is equal to 2. So we could just graph that first. So if you simplify the negative 125 over 10, that just becomes negative 12.5 when x is negative 2. So we want to go to negative 2 on the graph, on the x-axis, and then go down 12.5. Since my graph only goes up to 10, it's going to be a little bit weird. So I go to negative 2 on the x-axis, and then I go down. So my point would be around right here. Right there where you see that dot, so negative 2 and then negative 12.5. And then we have our other point, which is at x equals 2, the y value is negative 9 over 10, which is about negative 0.9. So x is equal to 2, and then negative 0.9 on the y-axis. So then there we have our other point. We have all of our points plotted down. So now you could see a lot better where the graph is going to go. So we see that it's going to be a pretty extreme like roller coaster across, since there's points that are like way down here and then way up here and then just everything else. So the main thing that you want to remember is the end behavior. So since the leading term is positive, the arrows are gonna end like this. So you want to keep that in mind. Here's the arrow for it going up and then it going down, because remember, it starts at a negative and then it's somehow gonna reach all the way to a positive, but we gotta graph all of the in between. And then you gotta remember, for the x-intercepts, I forgot to include that you also got to account for the multiplicity. So since right here, x plus 1 was in parentheses with the exponent of 2, the solution for that has a multiplicity of 2. So when x is equal to negative 1, it has a multiplicity of 2. X is equal to 3 has a multiplicity of 3. And then what we got to remember with that information as well is that when the multiplicity is even, it bounces across the intercept, and when it's odd, it crosses through. So at x is equal to negative 1, we have this point right here. So if we're coming from negative infinity, and then it's going to bounce at negative 1. It's not going to cross through negative 1 since it has a multiplicity of 2. So since we know that's going to bounce, we know that the graph is going to start like this. And it's going to go back down. You see that? So the graph bounces at that point. And then our y-intercept, we don't got to worry about that. It's just going to keep on going through. But then we have these other points right here. So we know that at some point it has to go back up and cross through right here at x is equal to 3. Since the solution x is equal to 3 has a multiplicity of 3, we know that it crosses the x-axis. And then the arrow is over here, so it has to go through all of that. So then you could estimate about how the graph is going to go. It's going to go something like this. So here's the end result. We have it coming up from negative infinity. It goes up, bounces right here at x is equal to 1, comes back down to the y-intercept, crosses through, but then it's not just going to go straight down like this because it has to go up to these points that we found by solving the functions at certain values, x values. So then it crosses through this point, and then right here at x is equal to 3, it cross distance as a multiplicity of 3, and then we know it's going to keep on heading upwards because we know the leading term test.